This equation is both linear and separable. So I'll show you how I solve it. First, let's take the y over x over to the right-hand side. So we have dy on dx equals minus y over x. And incidentally, I'm doing this as a separable equation, but it's also linear. So I'll do the linear technique next. So given that this is separable, it's a function of x times a function of y. I want to put the y's with the y's and the x's with the x's. So I'll divide by y, and I'll bring the dx over to the right-hand side. So we have minus dy over y is dx over x. And I put the integral signs on, and we integrate. So on the left-hand side, we have the natural log of y, but times minus 1 equals the natural log of x. And then we have plus c. We can solve this equation for y, multiplying throughout by minus 1. And then we can write y equals e to the minus natural log of x plus c. This is e to the natural log of x all to the power of minus 1, and then times e to the c. So this is e to the c, e to the natural log of x all to the minus 1. And so we have a, x to the minus 1, where e to the c is a, because e is a constant, c is a constant, so e to the c is a constant. Let's call it a. And then inside the brackets here, e to the natural log of x is x, so we have x to the minus 1, or y equals a over x. Okay, so that's how to do this as a separable equation. Now let's do the same thing as a linear equation. So via linear, we have integrating factor e to the integral of 1 over x dx. And so the integral of 1 over x is the natural log of x. So we have e to the natural log of x is our integrating factor. And so that's x. Okay, and so we multiply throughout by x, and we get x y dash plus y equals 0. Now this left-hand side packs up using the product rule in reverse, be the product of x times y. Okay, now integrating both sides, we have x times y is the integral of 0 with respect to x, which is a constant. Okay, so if we call it a here, our solution will match what we have up here. Okay, so we've now done this in two ways.